In this video, I'll show you how to construct this part. It's got several interesting features that I want you to see. Now, the drawing is in millimeters, so before you start sketching, come down here to the right-hand corner and set it to millimeters, grams per second. It's important that you do that from the beginning. There's the general shape, and I'm doing kind of the side view. You'll see why as we get deeper into this. That isn't right. Oh, I thought I was trying to do an angle. So here's the problem here. These two lines are not parallel, so let's set that. So add relation, click on those two lines, and make them be parallel. And while we're there, let's make sure that that's perpendicular. Okay, that's good. Now we can dimension that. Trim away what we don't need. And lastly, I need this to call out that angle. And I'll extrude this about the midplane. And that width is 50. Go ahead and add this semicircle. To the one end. Extrude that. And we need to add a hole in the end of that too, or in concentric hole, I should say. Cut the hole. Okay, I want to add these. There's a boss that sticks out on this other end. Oops, dimension tool. Make sure you locate that properly as well. Extrude that, and it's 12.5. And then we'll put, there's a hole in there as well. Put a hole in that. Okay, so what we need to do now is add these ribs on the side, and there's a really handy tool. It's the rib tool over here. In order to use it, we need a plane to locate it, because the rib isn't located on the edges. It's also not located in the middle. If it was in the middle, we could just turn on that front plane. So we're going to have to create a plane. So under features, go to reference geometry, and let's do an offset plane from this surface right here. And that distance, according to my drawing, is 3 millimeters. It's trying to go toward us, and we want it to flip the direction so it goes away from us. And let's see what we have there. So we have that work plane. So now we're going to sketch on that plane. In order to use a rib tool now, all you need to do is draw a line that represents the top of the rib. Now one thing we do know is that rib goes to the center of that arc, which is also the center of the hole through the part, and it goes down to this edge. Otherwise we would need to dimension it, but because we have those hard points, we can just click on those points. And that's all we need. You don't need to make an enclosed shape. So let's finish that. So I'm going to turn this plane off so it's not in our way. So it doesn't look like much right now, but that's the beauty of the rib tool. So if you go to features, rib, and it says to select an edge basically, and that's going to be that line that we drew. Now you've got several options here. Do you want to be a rib that goes in both directions, or you want it to go this side or that side? In fact, we want it to go that side. And then how wide is the rib? In this case, ours is going to be 6 millimeters. And one last thing, see this little arrow right here? It shows you which way the material is going to go. If that arrow is the wrong way, you're going to get an error. You want the material to go down from that line, and say okay, and there's our rib. So it's super quick and easy. And I can do the exact same thing on the other side, or I can just use the mirror tool. I think I'll probably use the mirror tool. It's a lot quicker. So I'll turn on that mid plane there. If you don't have one, create a mid plane by using your reference geometry. And now we'll mirror, select the plane to mirror it about, and the features will be that rib. You'll see a preview of it and say okay. Then I'll turn that plane off. And there's the part. Let's go ahead and save that part. Let's give it some kind of a name for now. And let's put that onto a drawing sheet. Now, we're going to, again, remember it's in millimeters. So as soon as you load this thing, you're going to want to switch the units to millimeters. We're still going to use ANSI dimensioning style. So ANSI just means the style of dimensions, but go down here and flip it to millimeters, grams per second. Don't wait to do that. You want to keep an eye on your units that you're using. And let's look at our views that we have. Because of the geometry of this part, we've got a lot of different views that we can look at. Just going to put some views on here to see what's what right now. Please don't give me a drawing that looks like this. I want you to see some of your options. I don't really care about that ISO right now. Some issues with these views. Because of this angled surface, a lot of this is very distorted. You wouldn't want to use that as a front view. Front view should show you the most information about the part. Same thing with this, because of that angle. Now the dead giveaway is whenever you have a feature that's supposed to be a circle, but it looks like an ellipse, or it looks like an oval, or you see this kind of situation here. Those are fine for ISO views, but not for orthographic views. So actually, our best front view, we have to think a little bit different, is this view. That would be the view I'm going to use for my front view. Now ordinarily, I probably wouldn't be too thrilled. Get rid of all that stuff. Wouldn't be too thrilled about using that as a front view, but you'll see how that's going to pan out. So from that view, I want to project my other views. And I could come back over to the palette, or I can come over to view layout and just do projected view. Click on that view. That's going to be my top. It's going to be my right. And there's a good ISO view. Now the ISO view is great for conveying what the part looks like, but remember we've got to be able to dimension this. I'm going to turn off those hiddens, dimension this accurately. So problems with this view and that view in terms of the distortion of the features, we've already talked about that a little bit. So what I'm going to do in this case is add an auxiliary view. The challenge is the real estate here. You don't have a lot of extra space, and this view is going to, because it's projected off an angle, it tends to take up a lot of room. So let's go up here to view layout. I'm sorry, not projected view. View layout and go auxiliary view. And what you have to do is click on the reference edge. So where do you want the view to be, what surface do you want the view to be projected off? In that case, it's going to be this surface because I want to get a view looking directly at that face. So if I click on that and then pull it out here, that's going to be my auxiliary view. And again, it's kind of hard to fit it in there, but that's not bad. Maybe challenging to dimension. A couple of things you'll notice, it's labeled view AA. There's this little arrow to kind of help you, guide you as to where that view comes from. But you see what's happening here. Now I'm going to see this arc in its true size and shape. I'm going to see this hole in its true size and shape, and also its true location. A couple of things here to fix. This center mark is good for the page, but it's not good for that view. So you want to rotate that so you can dimension to it. So if you click on that and you come over here, you see this angle tool over here. What happens if you click that arrow is it'll rotate the center mark around. In this case, you're going to rotate it around to 0. You can type in 0, but I just want to see how that works. Right, so now what you can do with that is use it as a dimension. So if I wanted to go from there to there, I have that. Let's see, so our other dimensions, now we are a little tight on space, so you'll have to use some care when you go to dimension this. The things we really care about on this view are really the diameter, that radius, and then the location of that hole in the part. As already discussed, these features are distorted now because I'm projecting them this way. The only thing that's going to be not distorted is this surface here. So don't put dimensions on this. We have other, that's why we have our other views to put our dimensions. So now I can, for example, if I wanted to dimension this dimension here, that's the true dimension. Now let's talk about numbers of decimals. Millimeter is a very small unit. When you call out 2 decimal places on a dimension, that's calling for a lot of accuracy. So we should fix that. So go up here to the top to go to options. And this isn't a minor issue. You should really pay attention to this. Go to document properties, go to dimensions, and here you're going to see your primary precision. And right now it's set for 2 decimal places. So what we want to do is put none on there. Okay. That's a much better way to dimension this part. If you have a dimension that needs a decimal, we'll add it. In this case, we don't really need that. Now, it is a little tricky to fit all these dimensions on here because you don't have a lot of space. So you may find yourself doing a little bit of, I don't like that, doing some rearrangements to make sure you got enough space here, because we do need to still pay attention to, zoom in a little bit, pay attention that everything is dimensioned so you don't have any unknowns. And again, as you're dimensioning, think about, is that a true size and shape dimension? Let me show you what happens. For example, if I were to try to dimension this circle here, you're going to get a note like that. It says true radius. It's saying true radius because the view is distorted. Don't put dimensions like that on your drawing. So if you see that, don't do it. Just go back and undo it. So I think I've got enough. I have enough space here on all my views, and sometimes I'll wiggle these around till I get enough room to fit everything, but you have enough room to fit all your views on. And don't forget to put your center marks and center lines and so forth. So that's how you're going to do an auxiliary view on the drawing sheet. Oops, I just realized I ran off the page. So it's pretty easy. Just use that view layout auxiliary view tool.